Imagine an aircraft so large that its wings stretch nearly half the length of a football field. Yet on enemy radar, it can appear almost like nothing. This is the B-2 Spirit, America's legendary stealth bomber, a machine designed during the Cold War to do something that sounded almost impossible: fly deep into heavily defended enemy territory, find some of the most important targets on Earth, and strike before the enemy can effectively respond. But here's the fascinating part. The B-2 was not simply another bomber. It represented an entirely different way of thinking about warfare. And decades later, its strange flying wing shape still appears to influence the world's newest stealth bomber designs. So why is this aircraft so difficult to reproduce? And why did America spend billions creating a machine that was ultimately built only 21 times? To understand the B-2, you have to go back to the Cold War. By the 1970s and 1980s, air defenses were becoming increasingly sophisticated. Radar networks could detect aircraft from enormous distances. Surface-to-air missiles could threaten bombers flying thousands of feet above the ground. For America, this created a dangerous question. What if the next war required bombers to penetrate one of the world's most heavily defended airspaces? The answer wasn't simply to build a faster aircraft. It was to build an aircraft that was extremely difficult to detect in the first place. That concept became known as stealth, and the B-2 would take it to an extraordinary level. Look at the B-2 from above. There is no traditional tail, no conventional fuselage, no large vertical stabilizers. Instead, the aircraft is essentially one enormous flying wing. This shape isn't just futuristic. It is part of the stealth equation. The B-2 combines aerodynamic shaping with specialized materials, coatings, and classified low observable technologies to reduce its radar signature. Its weapons are carried internally. Its engines are integrated into the aircraft structure, and even details that seem cosmetic can matter. Because when your goal is to make a huge aircraft difficult to detect, every edge matters, every surface matters, every reflection matters. The result is one of the strangest-looking military aircraft ever built, and one of the most technologically ambitious. The B-2 wasn't cheap, not even remotely. The aircraft's program cost eventually pushed the effective cost per aircraft above $2 billion, and there was a major reason. The United States originally planned to build far more B-2 bombers, but the Cold War ended. The Soviet Union collapsed, and the planned fleet was repeatedly reduced. Eventually, only 21 aircraft were produced. That meant billions of dollars in development, testing, manufacturing infrastructure, and specialized technology were spread across a very small fleet. The result? One of the most expensive aircraft programs in military history. But the United States wasn't buying an ordinary bomber. It was buying a capability designed around one fundamental idea: survive where conventional aircraft might not. So what actually makes the B-2 stealthy? There isn't one magic component. Stealth is a system. The aircraft's shape reduces radar reflections. Special materials and coatings absorb or manipulate electromagnetic energy. Its engines are positioned within the airframe. Its weapons remain inside internal bays rather than hanging underneath the wings. And its surfaces are carefully engineered to control radar reflections. But there's another important point. Stealth doesn't mean invisible. The B-2 isn't literally a ghost. Instead, stealth reduces the distance and circumstances under which an enemy can reliably detect, track, and engage it. That difference is crucial, because in modern warfare, a few seconds of warning can become the difference between survival and destruction. The B-2 wasn't designed to spend its life inside a museum. It eventually went to war. Its combat debut came during Operation Allied Force in 1999. 2 B-2s flew from Whiteman Air Force Base in Missouri to Kosovo and back. The missions lasted more than 30 hours. Think about that. Take off from the United States, cross an ocean, enter a heavily defended combat zone, strike targets, and return home. The B-2 later participated in operations over Afghanistan, Iraq, and Libya. Its combination of range, stealth, and precision weapons gave commanders something extremely valuable: the ability to attack distant targets without relying on large numbers of fighter aircraft to clear the path first.
And this is where the story becomes controversial. China has been developing its own long-range stealth bomber, commonly known as the H-20. Publicly available information remains limited, but some earlier imagery and wind tunnel models appeared remarkably similar to America's B-2. That immediately created a fascinating question. Was China copying the American design? The similarities are obvious. Both aircraft are flying wing configurations. Both emphasize low observability. Both are intended for long-range strategic missions. But here's where we need to separate fact from speculation. There is no public evidence proving that the H-20 is simply a copied B-2. And some analysts have argued that the final Chinese design could be substantially different. In other words, the silhouette may look familiar, but stealth aircraft are far more complicated than their silhouettes suggest.
And this is the part most people miss. You can copy the shape of a stealth aircraft, but you cannot simply copy its capability. The real challenge lies underneath the skin. How do you manufacture enormous composite structures with microscopic precision? How do you maintain stealth coatings? How do you control the aircraft without a traditional tail? How do you manage radar emissions? How do you integrate sensors, electronic warfare, and mission computers? And perhaps most importantly, how do you keep all of it working in the real world? Stealth is not one technology. It is an ecosystem. That's why creating a B-2-like silhouette is only the beginning. Today, the B-2 Spirit is entering the final chapter of its extraordinary career. But its influence isn't disappearing. America is already developing its successor, the B-21 Raider. China continues pursuing its own next-generation stealth bomber. And the race is no longer simply about building an aircraft that looks invisible. It's about sensors, artificial intelligence, electronic warfare, long-range weapons, data networks, and the ability to operate inside the most dangerous airspace on Earth. So did China really give up copying the B-2? The truth is more interesting. There may never have been a simple copy to begin with. The B-2's greatest achievement wasn't its shape. It was proving that a massive strategic bomber could be designed around stealth from the ground up. More than 3 decades after its first flight, the Spirit remains one of the most mysterious aircraft ever built. A machine that doesn't need to disappear completely. It only needs to disappear long enough. This is Skywatch World. And sometimes the most dangerous aircraft is the one you never see coming.